motorcycle way with a radius 0.3 meter. Okay, rotate freely about a fixed axis. A steady force of 10 Newton is applied tangentially for the wheel spring for 2 seconds. If the wheel moves from rest and its moments of inertia about the axis is 0.5 kg meter squared, so what is the final angular velocity? Given value here, we have R, radius 0.3 meter, and we have steady force here F 10 Newton, and T time taken 2 seconds. And moment of inertia I given here is equals to 0.5 kg meter squared. So what is the final angular velocity? Omega. Find omega. Our case here is motorcycle wheel. Okay, motorcycle wheel, and motorcycle wheel rotates. So for rotation, so we can use torque. Net torque equals to I alpha. Okay, for example here, diagram here, we have wheel. Now we have steady force here F 10 Newton. And here is acceleration at the center of wheel. So from center to net force here is R. So R here is radius, and angle between R and F here is 90 degree perpendicular. So we know that torque equals to RF sine theta, okay, equals to I alpha. Substitute value F 10 Newton, R 0.3, and theta 90 degree, and I 0.5. So we can calculate alpha. Alpha is angular acceleration. So we can calculate alpha. We use calculator. Then you get answer for alpha. So alpha equals to 6 radian per second squared. So now we can calculate final angular velocity. So you can use equation omega equals to omega naught plus alpha t. Okay, from equation here, we move from rest. Okay, move from rest, so mean that omega naught equals to 0. With substitute value 0 plus alpha 6 radian per second squared and t 2 seconds. So you get answer here omega equals to 12 radian per second. So the answer here is B, 12 radian per second. A heavy uniform plane of length L is supported by two forces F1 and F2 at point at a distance L per 4 and L per 8 from its ends as shown in figure 1. So find the ratio F2 to F1. So it means that L per 4 from n to f1 and L per 8 from another n to f2, and weight for heavy uniform plane center downward, direction weight downward. So at the end, from n to weight here is L per 2. So it means that from F1 to weight here equals to L per 4. So it means that L per 4 plus L per 4, so you get L per 2. And another n here from weight also equals to L per 2, half L. So it means that distance from weight to F2 here equals to 3L per 8. So it means that 3L per 8 plus L per 8, so you get L per 2. So we use torque. Total torque equals to 0. So it means that system imbalance. So as rotation at point weight. So it means that torque clockwise equals to torque anti-clockwise. Refer to diagram. From acceleration weight to force F1 is up here. Okay, so here is action line for F1. So angle from R to F1 is 90 degree. So from rotation, okay, we rotate here from R to F1. So it means the torque here is torque clockwise. And from axis rotation to force F2, here is action force for F2. So direction R2 here from acceleration to F2. So it rotates anti-clockwise. We know that torque is a vector equals to R cross F. So magnitude torque equals to RF sine theta. So torque clockwise here equals to R1 F1 sine theta 1 equals to torque anti-clockwise R2 F2 sine theta 2. So we substitute value. Here is R1 L per 4, F1 sine theta 1. Theta 1 here is 90 degree equals to R2 3L per 8, F2 sine theta 2 here is 90 degree. So sine 90 degree equals to 1. So ratio F2 per F1 equals to L per 4 times 8 per 3L. So you get answer here 2 per 3. So we can cancel L here. So ratio F2 to F1 equals to 2:3. So the answer is B. 2:3. Number 3. An ice skater is spinning with his arms folded inwards. Later, the ice skater stretches his arm outwards. So which of the following pairs of quantities will increase? So for initial position, his arms folded inwards. And final position, his arms outwards. So we can use conservation of angular momentum. Initial angular momentum equals to final angular momentum if no net torque acts on the system. So angular momentum equals to I omega. So I omega initial equals to I omega final. I for moment initial, I equals to mr squared. Okay, so mr squared omega initial equals to mr squared omega final. Okay, so now for period T, we know that equation for period T equals to 2 pi per omega. Okay, for final period T, okay, we know that initial R decrease but final R increase. So to balance the equation, so omega initial must be increased and omega final decrease. So you can balance equation for initial and final. So for final, omega decrease, so period T inversely proportional to omega, so T period increase. So answer for A period rotation increase is correct. So I equals to m r squared for a moment of initial. For final, we know that R increase. So R increase will mean that I will be increase because I final directly proportional to R. So the answer should be A.